I just want you all to know how amazing and smart and talented and respected you are, especially the Tuklahoma Foundation community. You all are doing some really important work for the developer community here, and a lot of the community groups. If you haven't already done so, I really encourage you to get involved with this organization and maybe donate some of your time or money or your employer's time and money to get involved. So one of the things that they do quite a bit of, which is very near and dear to my heart, is education and the free code camp workshops and so on and so forth. That's really, really important because code is becoming the new form of literacy. And literacy is the ability of an individual to access, analyze, produce, and consume information. So if we're not careful and we're not teaching people how to do this with code, we could create an equality gap. And that's concerning. We want to make sure that people have access to programming curricula so that, so that they don't separate from those who do not. And that has really important economic implications as well. So this is a big problem, or potentially a big problem. The challenge is that over the last 30 years, we've actually built a fairly complex system, so it's kind of hard for people to gain those literacy skills. And that's a complex system for both the users and the content creators. But it didn't really start out that way. The early internet technology was a bit challenging, but it was simple enough for non-computer scientists, people who didn't specialize in computer science as a field, to make full use of. And the complexity actually ended up growing over time as we looked for better efficiency. We tried to solve some problems. We abstracted away parts of our programs that weren't really user-friendly. So, if we compound the fact that we need to know code, but that's becoming a more and more complex system, here's your Avril Lavigne gif that you were waiting for if you saw the talk title. We have something that is fairly complicated for people who are new. So as Vance said, my name is Jory Burson. I'm an educator and a standards liaison for Boku. I represent web developers at the W3C, at ECMA International, which standardizes JavaScript, the JS Foundation, and the Mozilla Developer Network Product Advisory Board. So today I hope to explore, in a very accessible way, some of the reasons modern web development works the way that it does. And so we're going to look at some of important historical moments in technology, and we're going to look at it through a couple of different lenses because our industry is influenced not just by technical decisions, but also by economic, social, and political decisions as well. So for some of you, this may be a bit of a walk down memory lane, but for all of you, I hope that it adds just a skosh of context and understanding to your experience. The history of the web is a long topic, and we're going to try and cover it real quick. So some context to set. What was the environment like for the very first web developers? To keep in mind some context, before the World Wide Web was commonplace, the internet had been around for quite some time, and people were already used to using other protocols like FTP and Gopher to get information. It also used to be that sharing code was the default. We didn't have a term for open source because it was just inherent to share code. What mattered was the program, and the program was the means to an end, not necessarily, not the source code. The output was what was valuable. Most of the programs that we had were kind of used in service of other scientific pursuits, and that output was what people valued. Another thing to keep in mind is that early problems involved more about access and computing time and discovering information as key issues, especially after the Gopher system went closed source. It became harder to access that without paying a licensing fee. So, you may be familiar with this computer lib book. It's a very early philosophy book about kind of some computer science ideologies. It's very interesting and was very influential to our creator, Tim Berners-Lee. So this is the environment that he was working in when he invented the World Wide Web at CERN in Switzerland. He was seeing a lot of his fellow scientists sort of just connect and share freely and just sort of like interface with each other in this very ad hoc, but networked way. But they couldn't do the same kind of connection with their computers. Again, there are other ways to get information, but those were sort of onerous. There was this other additional concern that the lab was starting to rely on supply chain management and operations to go through these lengthy procurement processes for software, which were starting to get restrictive with their licenses. And he didn't want to see that happen and then see the domain of computers solely end up in the hands of computer scientists. So the question he was grappling with was, how can we make this information more accessible, more discoverable, and more usable to our constituencies? So as we know, between 1989, he built the HTTP protocol, he built a web server, he built a client web browser, and HTML. And in 1991, all of these end up being released outside of CERN to the broader public. Now, that doesn't mean that they were fully open source yet or anything, but they were at least available for the public to use, and others began contributing to the server software and writing their own web browsers. So the point is, he's able to allow people to use the system and simple code to share information and data pretty freely. Interfacing with the system required having some technical knowledge about the internet, but again, that was something that his users already had some comfort with, and the ability, as well as the ability to download and run applications and programs. So what did that look like? It was pretty groundbreaking at the time. These browsers allowed you to, and this is a copy of the first web page from about, the first web page was published in 91, and this is a copy from about 92, which is the earliest copy that we know of. So, but the browsers allowed you to view documents on other machines without really fussing over whether it would be compatible with your own, without worrying about whether that document would be compatible with your own. So it began to take the requirement off of knowing where the document, where the information is, to here is a tool for information discovery via hyperlinks. And then creating for the World Wide Web was also really fairly easy for the scientific community, because bear in mind, they're already comfortable with formatting requirements and ideas like SGML, Standardized Generalized Markup Language. So that was something that they had been doing with other scientific documents. So a little bit of HTML, easy peasy. It wasn't a stretch. And the tags are fairly simple. You had like title, A tags, headers, and a few tags that are now thankfully deprecated. But of the original 18 elements, there were still 11 in existence as of HTML4. So it kind of goes to demonstrate how sensible I think it was. So is this a recipe for success? Yeah. So it starts to, the World Wide Web starts to solve that information access and discovery problem by making sure the applications a user needs are easy to download and run, by leveraging the skills users are already comfortable with, like markup languages and FTP and things like that, by allowing the user to modify and publish their own content pretty easily, and also by building on top of stable, known standards like the Internet Protocol. So people really like this. This is awesome. The problem is now we need more people to publish content to the World Wide Web. We need a mass. So to publish content, you need HTML, and a lot of small things start happening to HTML in the early to mid-1990s that end up having a huge impact. Probably the most important, in my opinion, is that in 1993, Tim Berners-Lee convinced CERN to put all of his work into the public domain, and I think that's remarkable. Because rather than just slap a license on it and then go build a product company on top of that or anything, he was already thinking about how can we protect this knowledge in such a way that everybody can benefit from it, everybody can grow the platform, that it becomes an opportunity that is not just restricted to a few smart computer scientists or something like that. And I think maybe if he had not done that, we would be operating in an entirely different system today, and that's, to me, still blows my mind. He also leaves CERN and starts looking for a place where he can foster that and shepherd that technology. And he ends up, instead of going to Apache Software Foundation or the IETF or anything like that, working with the MIT to form the W3C as a hosting arrangement between 4 different universities. So again, making sure that that knowledge, that IP, it remains in a domain that it can be shared and improved on by the academy, by everyone, and not just a few select corporations. We also see the HTML start to get specified at the IETF. Originally, it was just sort of a extension of SGML, but over time, they decide that needs to be specified as its own language. It starts at the IETF and then moves to the W3C later in 1996, and then we see new versions of HTML adding other features and tags and stuff fairly quickly after that. So pretty cool. NASA homepage looks pretty cool in 1994, yeah. Another thing that's happening at this time is that the internet community is really embracing this cool new web solution, and that's going way beyond academic and scientific institutions into private and commercial organizations. People are creating a lot of different content for the web, and they're now looking to say, okay, I want to be able to add style. I want to be able to customize this. I want to be able to separate my presentation from my content. And that idea predates the web, actually. But there really wasn't a good solution for this in HTML. The primary presentation problem in HTML was style tags. That's what we had. So people used those and hard-coded them into their pages, which is really not very good for. We frown on that. Also, people wanted to be able to use different styles depending on whether they wanted a presentation for printing, if you wanted to print something out, if you had a screen presentation, if you had some other kind of editor, if you were publishing to the web. So again, existing style sheet solutions didn't really allow you to do that, and they weren't very dynamic. So we can find content, we can access it easily, and we can publish our own content, but how do we make it look good? That's the question. Obviously, a lot of people see this presentation problem and start discussing the issue on mailing lists. Lots of ideas get kicked around. One idea that thankfully did not stick around was JavaScript style sheets. Yeah. But in 94 and 95, Bert Boss and Hakam Lee come up with a bunch of different proposals, and they start testing them in Argo and Mosaic browsers. And the result is that they combine both aspects to develop cascading HTML style sheets, science sheets. The H ends up being dropped, so we just have CSS. They end up taking that work to the W3C to get published alongside HTML. And we have some pretty rapid-fire evolutions in CSS in the mid-90s. So one important thing to note is that in CSS3, the work becomes modularized. Instead of getting standardized as one big chunk of work, we now have the ability to make improvements to CSS with things like media queries and MathML and transforms and selectors and stuff in smaller chunked ways, which is really important. So we're not waiting on a whole big chunk of work to be approved and implemented before we can start to use new cool stuff. So at this point, the best practice is to define your content in an HTML file and author different style sheets for whatever presentation styling that you want. So the problem is solved, right? Not really. Unlike HTML, which was adopted pretty quickly, CSS didn't have quite as easy time in the 90s getting implemented. There were a lot more browsers which really loosely interpreted the standard if they were even following it at all. Lots of competition among those browsers for users. And they were all looking to influence the direction of CSS for the benefit of their own product. So it took years to get some browsers to adopt this CSS standard. And even then, there were a lot of inconsistencies, bugs, and other quirks, which we will take a look at a bit later. So we can find, access, publish, and style content on the World Wide Web now, but we have a new slate of questions. If you're a web developer, the question is, how can I create a consistent experience in the Wild West world of browser competition? And these are just a few of the earliest browsers. If you're a browser, how do you stand out and gain market share on the web, which is an exploding platform where there's more and more people coming to it every day? And then third, computing performance is improving drastically. So now that we have more powerful machines, how can we start to add functionality to web presentations that take advantage of the web that you really can't do right now with HTML and CSS? So these are the questions that were very much live when commercial activities really started to shake things up. The problem is very much market-based here. There are all of these browsers on the market, and web usage is exploding, as we discussed. But Mosaic, which is actually a browser that was authored by a supercomputing group at a university, is the market leader. In 1994, Mark Andreessen decides to form a company called Netscape Communication Corp to go after that because he sees this commercial opportunity. And his singular goal is, I want to unseat Mosaic and be the dominant browser. And to really do that, he needed something that would set it apart and demonstrate that it could be even more dynamic. And he believed that there perhaps needed to be some kind of glue language that was easy to use by web developers and part-time programmers to assemble components such as like images and plugins and that kind of thing, where the code could be written directly in the web page markup. So he hired Brendan Eich initially to embed Scheme into their browser in 1995. And then before Brendan was able to even get started, Netscape Communications started collaborating with Sun Microsystems to include Sun's more static programming language, Java, and in order to compete with Microsoft, which was really starting to shake up the world. So they decided that the scripting language that they should build for the web should complement Java and have a fairly similar syntax, so they kind of abandoned that Scheme thing. So Brendan comes to Netscape, and we kind of know a little bit of this history. I'm sorry, it's a little small here. JavaScript is originally written inside of, it's rapidly prototyped and rapidly standardized. It's originally written in about 10 days in May 1995. It's shipped as a beta in Netscape Navigator 2 in November of 1995, released in the third beta release of Netscape Navigator 2 in December 95, so just rapid. And the result of all that effort is that they beat Microsoft to the punch. Microsoft releases VBScript and JScript, which ends up being a reverse engineering of JavaScript in 1996. They caught them on their heels, so cool. That's great. Another offensive move that they took was taking their work to ECMA International to standardize. They kind of were thinking, okay, if we're going to beat this giant, the Goliath of Microsoft, we need to get the rest of the industry bought into this standard before Microsoft goes out and beats us in terms of making their thing, JScript or VBScript, the de facto standard. So they go take this, they start shopping it around. They almost took it to the W3C, and the W3C said, no, we don't really think it's a fit. So, and I think that's funny. So now it's standard. That's why it's standardized at ECMA. And kind of work proceeds for the next couple of years with ES3 being released in 1999. JavaScript is one of the best known of the implementations, but others like ActionScript and JScript are other implementations of ECMAScript as well. So, all right. But just because there's a standard doesn't mean that that standard is going to get implemented. Some developers decided to take on the very difficult task of trying to make their sites work with Netscape Navigator and IE and other major browsers, but really couldn't afford the time. the differences in language implementations and the different and proprietary document object models remained. So there were a lot of obstacles to widespread take-up of JavaScript on the web early on. And over time, it became pretty clear that although that Microsoft really had no intention of cooperating or implementing proper JavaScript in Internet Explorer, even though they were part of the standards process for that. So it's kind of funny. So the markup and the styles, style sheets in JavaScript aren't really like the technical issue, aren't really the issue in and of itself. The technical issues are really about the incompatibility of browser technologies. It's not really the tech here that's making the decision. It's the business. It's the business of the web and the product of the web that's driving these problems for us as web developers. And all of these companies are trying to do that product direction for the web in a lot of different ways, in very different ways. So we have that kind of conflict and tension in the market that's been building. And on top of that, people are building businesses on top of the web platform, and older organizations are investing in it as well. So by the end of the 1990s, we have just all of this tension building up in the system with more people coming online every day, more of this market kind of drama happening, and all of that kind of thing. So there's a lot of big potential for money and lots of technical decisions being made by somewhat speculative business models. So we have a bubble. And that is kind of what we see happen between 1995 and 2000 with the dot-com bubble bursting. And the issue here then becomes that the ecosystem kind of loses its money. A lot of programmers are laid off. A lot of people lose faith in this as sort of a platform that you can build businesses on top of, because it doesn't really seem like there's a perceivable business model here. I think a little bit on the plus side, maybe, we have a bit of a consolidation of browsers as well. But the browsers are kind of insulated from it because they're publishers, and the publishers are more affected than the carriers. So I thought this quote was pretty, it spoke to me. Namely this line, "Nothing important has ever been built without irrational exuberance." And sometimes we have that in our field, some irrational exuberance for a new technology. And I think that can be really awesome, so long as we're kind of also thinking about how that exuberance benefits the underlying infrastructure. I was also going to put the Yata meme here, but I decided that maybe that wouldn't go over so well. So technologically speaking, we start to enter the next decade of the web in a kind of sad place. We kind of had that popped dot-com bubble, had depressed people, caused a lot of doubts, as I was saying, about the web's commercial potential. In addition, we have the browser wars that are heating up. And these differences made it really difficult for designers and programmers to make a single website work well in both browsers. And that's what led to these lovely little tags like best viewed in Netscape, best viewed in Internet Explorer, so on and so forth, that sort of characterized a good web page back during that time. We also see the rise of quirks mode and standards mode, which you had to trigger in your doc type declaration. So this is, I think, primarily a result of the CSS box model bug, and a lot of web developers lost a lot of time and hair over that. We have a lot of competing visions for DOM, what the DOM should look like, what JSON should look like during this time. Another, let me click, there we go. Oh, I forgot I did that. Another kind of issue is that we've got a lot of open disagreement in the text standards arenas, JS and HTML most notably. In 2004, there's a bit of a fallout at the W3C over XHTML, and that actually leads to the birth of, and that tension had been building for a while, but that ends up leading to the birth of the WhatWG, who now kind of takes care of the living standard of HTML, and a lot of that work isn't done as much at W3C anymore. We also have the work almost completely stopping on the JavaScript standard between 2000 and 2005. But work on other things like ActionScript continues. And thankfully, we had projects like Tamarin, which was ActionScript's virtual machine, and Ajax to kind of like lift us out a little bit of that little filling the gaps. We have a pretty explosive adoption of mobile devices that happens in 2007. That's another thing. With the birth of the iPhone, native app development, that kind of thing. There's a rise of SDKs, and basically the whole experience of native app development is frankly a lot more stable and possibly lucrative, so lots of people switch over to that. In the open source side, open source software sort of answers with tools like PhoneGap and jQuery Mobile in the late 2000s, but I think the iPhone was something that really took the wind out of a lot of developer sales as well. And then we started moving to the client side as well during this time frame. We see a rise of client-side applications, single-page web applications, that kind of thing, because we want to provide more features and add functionality to our site's users, but we can't really approximate what that site's performance is going to look like, given that a user's context is changing from the desktop to a laptop with Wi-Fi to mobile devices on all kinds of different data plans, that kind of thing. So we start to ship everything over the wire and drive the app from the front end and build and rely on RESTful APIs for everything else that we need. I just kind of got off. Another thing that happens is we start to see a rebranding and repackaging of the concept of open source. So as I mentioned earlier, we didn't really have that in the 80s and early 90s, but we see in the mid-90s, Tim O'Reilly sort of coined this phrase, open source software, which starts to put the emphasis on the rights of software creators over Richard Stallman, whose emphasis is on the rights of the users, the person's purchasing the software. So that becomes, Tim O'Reilly's sort of brand of open source is a lot more palatable to the enterprise, and we see a lot more companies start to think about open source software as something they can seriously bring into their organizations. I called this a lost decade because for me, there was just a lot of fragmentation and disagreement, which is occasionally sort of like broken up by bright spots like jQuery. But I don't know if a lot of web developers were really excited to be doing web development during this time. I say I don't know because I was in middle school, so I wasn't really doing a lot of web development at that point. All right. So fortunately, we also see during this time, because the standards track has kind of failed us, open source software really starts to take over where the standards track failed. We make it work without the help of browser vendors for the most part. We get our first edition of JavaScript, ES5, is published in 2009. That's the first time the standard is published in 10 years. That's crazy. Could you imagine going 10 years without a new release of? Some of you are like, please, can we? Yeah. I'll relay that information. We also get Node, which allows us to consider thinking about JavaScript outside of the browser context in 2009, and that's pretty mind-blowing. And we get HTML5 in 2014. So I mentioned the WhatWG sort of taking over HTML5 and HTML and really leading the charge. One of the things that they've done is also start to modularize the release of HTML5. So you can start to get new features early without having to wait on some major edition of the language, and that's cool. Other things we start to get during this time frame. We start to need package management. So we've been building a lot of client-side apps, and the problem is that the packages we're using to bake those client-side apps are really hard to keep track of. They're getting harder and harder to keep track of and manage because they are themselves also open source projects. So we start to think about tools that help automate this process of downloading and upgrading libraries from a central repository, NPM, yay. And then, since that package functionality isn't going to come down from the browser anytime soon. So one of the implications here is that you can just share your package JSON file, and that's the recipe instead of like sharing the whole cake. And B, web developers need to start learning to use the command line if they're going to be using these tools, whereas prior they really didn't have to. So we start to get some command line tools that start to make our lives hopefully a little easier, but maybe a tiny bit more complicated, but not that bad, right? So in addition to managing packages, these tools can help us scaffold new projects. They can help us start linting and testing our code, running development servers for us, all in one easy command. And there's a bit of competition here in the kind of 2010 to 2013, 14 for like what's the best command line tool for JavaScript. We also see the need for module bundling. So JavaScript wasn't originally designed with a way to import code from one file to another. So for the longest time, organizing JavaScript code in multiple files required you to load each file with variables that were shared globally. In 2009, CommonJS was started with the goal of specifying an ecosystem for JavaScript outside the browser. A big part of CommonJS was its specification for modules, which would finally allow JavaScript to import and export code across files, like a lot of other programming languages allow you to do, without resorting to global variables. The most well-known implementation of CommonJS modules is in Node.js, which is now kind of changing. I think there are some updates in the Node module world. The browser doesn't have access to the file system, which means loading modules in this way is very tricky. Loading files has to be done dynamically, either synchronously, which slows down its execution, or asynchronously, which can have some timing issues. And this is where the module bundler comes in. It's a tool that gets around the problem with the build step, which has access to the file system, to create a final output that is browser compatible and doesn't need access to the file system. So that's a nice helpful new tool. Another helpful new tool we get, Transpilers. Transpiling code means converting the code that's in one language to a code in another similar language. And this is an important part of front-end development, since a lot of times browsers are really slow to add new features. These new languages were created with experimental features that transpile to browser-compatible languages. So for CSS, we have CSS transpilers and preprocessors like Sass and Less and Stylus that do that for us. And in JavaScript, the most popular transpiler for a while was CoffeeScript, which was released in 2010, whereas nowadays we're using either Babel or TypeScript. Oh, I'm getting a 1-minute warning, so I better get going. So anyway, so the point is we've got this a history of problem solving and responding to these new problems with new technologies like module bundlers and transpilers and so forth. So what's the next decade going to bring us? That's sort of the question. Where are we going? I don't know. I don't have a crystal ball. I can't tell you that. But I think one direction is we're going to start to see open source process and open standards processes really merge together. We're going to see the innovation and the kind of community-driven efforts of open source start to meet with the documentation and the governance and the sort of like longevity, I think, of standards meet. And I think that's really awesome. We're going to be focusing on standardizing proven APIs and not innovating in committee, which is which was really the big problem in the 2000s with JavaScript. We're going to codify what we know works and what we know works really well. Ethan Marcotte had this really great quote last week that I just was like, I got to work this in. He said, building applications that withstand the web's inherent variability, because the web is going to change. And he said, we need to start thinking about designing patterns and not pages. and emphasizing the conditions and features of the web, not specific devices. Contexts for people are changing rapidly, and we're not all browsing the web in the same way. And so I think there's going to be a lot of technical innovation around how we start to think about those patterns and not pages, that sort of ideology. And I think perhaps maybe most importantly, I think we're going to be opening up the process and focusing on people with things like technology governance, ethical considerations of technology, not just for our users, but also for people who are working to create technology. Because how we create technology is way more important than what we create. So let's take care of each other while we're creating it. Thank you so much for listening.